I applied for, I just forgot to start the recording until now, so this part won't be on the recording. But okay, since there are no questions, let's go on to the next question. All right, well, I think that I'll just start talking about this problem since, well, let's work our way through it. So if you notice, just at first glance, this question, you can't just kind of look at the angles and just immediately tell the answer, because the only angle you're given is this angle right here, which is conveniently not part of any kind of isosceles triangle, right? So this suggests that you should start with a variable first and then see where that takes you. So can anyone, okay, let's call this angle X. Can anyone just tell me what other angles are equal to X in this picture? Right? QRP is one of them. And QPS is the other one, right? So now this is actually enough to solve the problem. So what is X? That's what we need to solve. QRP is X. So what is X? Remember that all the angles in a triangle have to 180 degrees. Well, the answer was 35 degrees. Since all the angles in a triangle have 280 degrees, we can use this big triangle QPR and the sum of the angles is 3x plus 75, because if you take a look, all these are all the angles that are part of this big triangle. So 3x plus 75 is 180, and solving the equation, you get x is 35. So one thing I want to point out is that for this question, it's almost always, and for other questions, it's almost always necessary to just choose a starting point and just let that be any kind of variable, and then try to find every other angle in the diagram, or at least every other important angle in the diagram, in terms of that variable. And then after you've done all that you can for that, try to see if any new information can be used. All right, so that's kind of the method to solving this one, and it's a very similar approach to many other ones. All right, so are there any questions on this question? Alrighty. Here's this next one. This one goes a little bit further back to well, last class where we talked about angles in regular shapes. So I want to see if anyone still remembers that. So what is it? I'll just draw in what it's asking for. It's asking for angle WV, which is this angle right here. And I believe that this question is quite hard to just approach straight up. So I think, again, I'll try to walk you guys through this. So I think the first thing you should notice is that this is a square, equilateral triangle, and regular pentagon, right? And one thing with these shapes, they're all regular shapes, which means that all their angles and all of their side lengths are the same. So it's very important to realize, in order to solve the problem, that VU and WV are equal. So that means that WUV is actually an isosceles triangle. All right. And so what does that mean? That means that this angle U is also equal to the angle UWV, right? So that means we don't actually have to find every single angle within the triangle. We only actually need to know just one of them. And so how do we approach this now? I think just it's pretty clear that there's no way to find this angle directly. There really isn't any way to do that. Instead, look at the triangle and see what other angle there is to try to find. And spoiler alert, there is one angle, WVU, this big angle in the middle, right? Now, how can we find the measurement of this angle? Well, this just goes back to the square, equilateral triangle, regular pentagon. Since these are all regular shapes, and we know that formula from last class, or you memorize the angle measures, you can find out exactly every single angle in this part right here. And all it becomes is to find a way to kind of piece everything together to get this angle WVU, and then just use the sum of all the angles in this isosceles triangle is equal to 180 to kind of work backwards to find this angle U. All right, so I want everyone to kind of try to use that method and to see if they get the right answer. And again, if you do have any questions, like maybe I didn't say anything or say something not that, sorry, if I didn't say anything too clearly or need another explanation, just feel free to ask. And this is pretty beneficial if you do.
那是多少？是108，所以这个角就是108，一个 pentagon 的角就是108，是吧？那你现在就能算出这个了。
All right, let's kind of go through this step by step again. Okay, so first, what is the angle measurement of this equilateral triangle PVW? What's this angle? Right here in red. Right, it's 60 degrees. All right. What's the pentagon? This angle right here, RVU. What's this angle? It's 108. And now, how do we find WVR? What's this angle in the middle right here? Right, it's 30. And this is because you take the angle of the square, PVR. We know that the square is 90 degrees in every single angle. So you just take this 90 degrees, and since the triangle accounts for 60 degrees here, that means the rest must be 30 degrees. All right, so that means that WVR is 30 degrees. So if I kind of just take the triangle WVU and kind of enlarge it, we know that this angle is equal to 30 plus 108, that's 138. And we also know that VU and WV are equal in length. And so now we need to know what angle WUV is. So if we know this isosceles, we know this angle in the middle. So now just calculate what this angle is in blue. And that would be the answer. All right, so to the people who had the right answer, good job. It was 21 degrees, or A. So the way to finish the problem is to note that since it's isosceles, these two angles are the same. So 2x plus 138 equals to 180 because all the angles in the triangle have to add up to 180 degrees. And so 2x equals 42 and x equals to 21. Are there any questions? And I do encourage everyone to just submit whatever answers they're thinking. Like it doesn't matter if it's wrong. I guess as long as you're just trying, and eventually you will get it right. All right. Okay. Well, next we have a little bit of a different kind, but I want everyone to try this problem out. All right, one thing I want to point out first is that we can't solve for x and y individually. So don't try to do that. It asks for the value of x plus y. So look for a way to relate x and y to each other in some kind of way, and then you'll be able to figure it out, I guess. Seeing that this question is a bit difficult, so I'll give a few hints. So first, since it's an equilateral triangle, every angle is 60 degrees. This is because all the angles are the same and they have 180. So every angle is 60 degrees. And we know that this is a square, so this angle here is 90 degrees. So we need to find x and y. And just let's see. What method have we been using for every single problem this past in like the past half hour? What method do we use to kind of find unknown angles, so to speak? Okay, so it was all of the angles in the triangle at 180 degrees. And does this help us? Well, we need to find a way to incorporate x and y. Well, they're part of different triangles, right? But these triangles are related because of this 90-degree angle in the middle. Since this is a straight line at the bottom, that means that every angle adds up to, every angle like along this like line adds up to 180 degrees, because a straight line is like half of an entire circle, so to speak. So this is 180 degrees out of 360, so it's just 180, right? And then since the square in the middle adds up to 90, that means that these two angles on the sides right here, they add up to 90 as well, because the two angles and the 90-degree angle in the middle have to add up to 180. So the two together also add up to 90. And now, what happens if you add up every single angle in both of these two triangles? Triangle 1, triangle 2, what do you get? Well, I see some people have it. It's that x plus y, then plus 60, plus 90, plus 60 equals to 180 plus 180. Where essentially I'm adding all the angles in two triangles. So that just means I'm adding 180 twice, which is on the right side, but also x, which is this angle, y, which is this angle, and then one of the 60s, another one of the 60s, and then 90 represents the last two angles that we haven't added. And so if you just move everything else to the other side, x plus y equals to 150 is what's left. All right, so I think this problem is a great example of just using everything, that all the information that you're given, and as working within those bounds, not trying to look for stuff you don't need to. So since it only asks for x plus y, it probably suggests that you don't need to find x and y individually. And I guess another part of the problem is just look to be creative. So there are only so many different ideas or concepts that can be applied in each of these types of problems. So be sure to try to exhaust your options and look to, I guess, see what is and isn't applicable in this situation. All right. So here's the next one. Just a heads up, the meeting's gonna be closing in about 2 minutes. So once that happens, just please rejoin. I've just marked the equal sides in the diagram, so it's a bit easier to see. Yeah, just think about it. Maybe copy on the diagram, and we'll talk about it in about a minute. So let's keep working, and see you soon. All right, welcome back. A few people, but all right. So I guess I said I'd start talking about this after we rejoined. So here we go. This is pretty similar to a lot of the other ones, where we have a lot of isosceles triangles and an angle. All right. So this is a little bit different in that we're given this vertex, or oh wait a minute. We're given this angle, which is not equal to another angle in this picture, at least not immediately. But we do know that it's part of the isosceles triangle ABC, with AB equals AC. So that means that the bottom angles, or the base angles of ABC and ACB must be the same. So since all the angles in the triangle have 180 degrees, this means that each of those base angles must be 70 degrees, because 180 is 40 plus 2 times 7. And next, there are a few ways you can go about this. I think the most logical way is to now look at this angle BDC. Since BD and BC are the same length, this means that it must be equal to this angle up here, angle C, because of isosceles triangles. And so now we can work backwards using all of the angles add up to 180 degrees in a triangle with this triangle BCD. So right here. And that means that angle CBD, this smaller angle, is 40 degrees, because 70 plus 70 is 140, 180 minus 140 is 40. And now finally, since angle CBA, so this big angle CBA is equal to 70, and the smaller angle inside of it is equal to 40, that means what's left must be 30 degrees. So can everyone actually hear me okay? Someone told me I'm laggy. If I am, there isn't much I can do about it, unfortunately.
Yeah.
All right, well, if you do have any problems, please do tell me. That's the only way I can do something about it. So does everyone get the problem at least? Any questions? All right. Let's move on. The answer was 30, as I just erased. But if you did get 30, good job. And let's go to the next one. So try this one on your own. It's, again, very similar to that last problem we did with the pentagon and the square and the equilateral triangle. It's kind of the same ideas. So try to work through this one. Okay, let's step through this, okay? I see, almost you got it right. Okay, who wants to tell me what this angle is? PUT. What angle is this?
90 degrees.
No, it's not. Angle PUT is the hexagon angle, not the square.
120 degrees.
That's right. This is 120. And I guess as you said before, this angle is 90. All right. And the equilateral triangle, as I said before, it's 60. So what does this mean angle TUV is?
90 degrees.
That's right. Since we're given the other angles are 120, 90, and 60, this means that the last angle must make it so that all four angles add to 360 degrees, since these four angles form like a complete circle, and a circle is 360 degrees. So that means that, again, it is 90, since 60 plus 120 is 180, plus 90 is 270. 360 minus 270 is 90, right? And now the last part, which is very similar to the earlier problem, where we're dealing with regular shapes. This means that all the sides are equal. So UT and UV are equal. So this means this is an isosceles triangle. Since angle U is 90 and it's isosceles, I think we can tell that the answer is just 45, because 180 is 90 plus 2 times 45. So that would be how you would go about finding this. So if you work backward, I guess that's where I think the logic for the solution comes from. It's first you draw the triangle. Notice that it's an isosceles triangle. So that means that you just need to know angle TUV. How do you find that angle? Well, we know all the other angles next to it. And then we can use that to find angle TUV because they have the 360. All right, so this isn't just some like random kind of just guessing or randomly stumbling upon the solution. There is a logical path that you can follow to get the answer. Right, is that clear to everyone? So are there any questions on this question? All right, well, if not, let's move on. Probably won't get through all the questions, but that's okay. So here, I guess, is a change of pace. Find this angle W in the diagram, and these are parallel lines. I'm actually just going to do this one straight up, since this might be a little bit of a new concept. So the main idea with this is to draw assisting lines. So the most natural assisting lines would just be parallel lines through C and D, parallel to AB and EF. And this is very useful because with parallel lines, we get a lot of angles are equal that we wouldn't have if we didn't parallel lines. So I'm pretty sure I went over this last time, but these alternate interior angles right here are equal. I'm pretty sure I went over this. If I didn't, I can explain as well. But yeah, with parallel lines, angles that are kind of corresponding to each other are equal like that. And essentially the idea is you can go down the line with, here I'll just mark them with different colors, these angles all being equal. And so I guess I'll get this started. Since blue angle is 45 degrees, it must be 45 degrees here. And since the green angle is 50 degrees, it must be 50 degrees here as well. And now we just need to find the right angle. And how do we do that? Well, it's simply just 85 minus 45, which is 40, because it's this angle C just got split into two angles. So they must add up to 85. 85 minus 45 is 40, and the right angles are equal. So this is also 40. and W is just 40 plus 50, which is 90 degrees. All right, I kind of went over that a little bit fast since we do. I do want to get through this one to the next one, but if you do have any questions, please do ask. This is a pretty important topic, so. All right, well, if there are no questions, I'll just summarize. If you do want, with these questions, just draw assisting lines that are parallel. Very, very helpful. And as you can see, it just solves the problem. All right. Next one, we have a very similar question to the last one. And I'll just mark these are parallel. And so what do we do here? All right, well, I'll give you a hint. It's just drawing a parallel line. So if you draw a parallel line through D, parallel to this line over here, then you'll see that this angle is 90 degrees. And this angle here is equal to this 52 here, because AB and DE are parallel. And this, you can kind of think of it as if you take these two lines, BC and DE, if you take these two lines and kind of like smush them together, so to speak, where they would kind of overlap, or you can think of it translating it to the left, you'll see that it's going to be the same scenario with this angle and this angle being corresponding to each other and therefore being equal. So that would mean that this is also 52. And then when you add them, 52 is 142. So again, if you do have any questions, please do ask. I know this is probably going a bit fast, but all right. Well, I guess this is going to be a last question. And first thoughts. The diagram looks pretty complicated. Don't be intimidated by it. And find angle BA. Good luck. All right, so let's work through this. First, notice that we're not given any information on these lines, so you can't assume that any of the lines are parallel. But if you can somehow show that two lines are parallel, that would be a very useful in this case. So, first of all, we see here that this is 50 and this is 50, right? So what does this tell us? That these two angles are equal. What does that tell us about this diagram? What specific information can we glean from this? Well, we can see that AE and FD are parallel. These are parallel lines because these corresponding angles from this one transversal gives the exact same angle. So that must mean that the two lines are parallel. And now, how do we use that? Well, we need to know BEA, right? And we know these two lines are parallel. So there are multiple ways to go from here. I guess one way to do it is, since the lines are parallel, angle BEA is equal to angle EDG, because they both correspond to they're both corresponding angles from the line BD intersecting with the pair of lines AE and FD. And I won't have you do this since it's pretty simple. This is 90, this is 60. So the last angle must be 30 degrees since all the angles add to 180. So this means that angle BEA is also 30 degrees. All right, so are there any questions on this problem? Okay, well, there was actually one more problem left. We're not going to do it since it's 6 o'clock. If you're interested in trying to figure it out, here's the problem, here's the answer. So I'll leave it like that. So I know this class was pretty difficult, and I'm afraid the recording might be out. But if you guys want me to post the link to the spreadsheet, not spreadsheet, to the slideshow with all the problems on it, so that if you want to view the problems we went over in this class and also the previous class, I can do that if you guys want, and then you can also review with maybe your parents, or you can also email me any questions on any of these questions and I'll answer them. All right, so does that sound good to everyone?
Thank you. Bye.
All right, well, bye.
Bye.
Fun. Bye. Cool. See ya.